Hello guys, this is Thanos 3D Prints, and this is the second video regarding software in 3D printing. The second software that is crucial for you to 3D print anything is a slicer. Now, what is a slicer? Your 3D printer is really an unintelligent machine. It doesn't understand geometries, it doesn't understand temperatures or speeds. What it understands is very basic commands. So, to get your geometry to be printable by your printer, you have to slice it down, therefore the name slicers. And what that does do, it takes the geometry, it creates distinct layers of either set or variable heights. We call them layers, and those layers get further transformed into Cartesian coordinates, and based on the parameters, the printing parameters, they can translate it into tiny slices of material, of item you're creating, and those layers are superimposed upon each other, which ends up creating your 3D printable item. In the screen, you are seeing a Bambu slicer. It's a really good slicer. It's based on Orca slicer. It's another good slicer. There are various um, exceptional slicers. You've got Prusa, you've got Bambu, you've got Orca, you've got Reality, Cura. I mean, uh, you don't really. Most of the capabilities are widely available in all of them. Not all of capabilities, but for the vast majority of early adapters and introductory purposes, yeah, you can use any one of them. Now, let's walk through the slicer and what we see here. First of all, to the center we have the item that I intend to slice. It's a test pebble I created from another video, so it's possible that you recognize it. In here you see the printing plate. Now that's based on the parameters I gave it, and gives you the surface in almost it's a rendering. Now you can go right up here and open this menu, and for Bambu Slicer the menu is pretty much like this one. And let's look at how that menu, what that menu does for us. Here you see the printer information. Okay, exactly here. So here you've got the name of the actual machine. I run an X1 carbon mainly, the type of plate, the nozzle diameter, and the type of flow. Now the nozzle diameter almost always is 0.4. That's the default nozzle diameter. Most of the things you will build, and most of the things I've seen. And the nozzle diameter really impacts two, three things. First of all, layer height. You really cannot fall under 0.40% of the diameters in height. So for a 0.4 diameter, you can go down to 0.16 maybe. Under that, you're probably gonna be getting. You need to do a lot of fine tuning, even if it's a question whether or not you can actually do the printing. It also impacts the line width. That's the distinct lines that create the infill and the walls, and it really impacts the speed of the printing. The smaller the diameter, the less material you can extrude, the more layers you're gonna need, and therefore the more time you're gonna need. It also indirectly impacts weight, because at the same infill percentage, as you have a smaller diameter, you're gonna have less air in between the lines, because 3D printing is not perfectly homogeneous across the various layers and the various in between layers. So as you have finer and finer lines, you're gonna have less empty space, and therefore a little bit more weight to your items. But it's a little bit; it's not that much. If you have an AMS for Bambu, especially, this is you have a small area in which it gives you the various types of filaments and their identity. You can press on them and see you get up a drop down menu with filament settings, a complicated menu. I will go over this in a different video. It's because it has a very large amount of information that are relevant, but really for a new initiate, they are probably too much for you. In most cases, you're gonna find presets online, and even if you don't, you can easily pick up a spool, see what the manufacturer is saying, and just fill in the relevant information right here. Okay, and here we've got the part in which it describes the process. That's a very important piece for you. Now, the process has several subdivisions, and let's talk about them. Here you see the quality. Okay, the layer height is what I told you. It's essentially your the how thick is every layer. and the layer height is almost always going to be a multiple of your total object's height. And the layer height has a minimal and maximum value. You can press it at 40% of your nozzle diameter as a minimum, but you're not going to be able to go under it without by having also guaranteed quality. So your, your layer height really uh, is really part your decision, but it's also constrained by your equipment. Now, the layer height, the higher the higher the thicker the layer, the higher the height, the faster your print is going to be, but you are going to have significant quality deterioration. The outside, the optical effect your item is going to have is going to be significantly lower. Your speed is going to be significantly lower as well, and you may have some structural problems because, as we said, the higher, the thicker layers may not adhere as good as other layers. So if you have particularly high mechanical loads, you may end up having situations that your entire thing breaks down, and you don't want that. You don't want your monitor falling onto the ground. As you go in lower and lower layer heights, you start to almost have an almost injection molded feel, like the outside surface is almost perfectly fine and continue, so you do not see the layers interrupting. As a matter of fact, if I slice here, you can already see this is what we see even in an actual print. You see those lines. Now those lines become less and less visible as the layer line is smaller and smaller, because our eyes start to not be able to distinguish between 2 points right around at 0.10 millimeters. Depending on the filament, depending on its finish, depending on the geometry, depending on lighting, and just the average observer, that 0.10 may be a hard limit or a soft limit. Some filaments you can see the layer lines even at 0.10. Other filaments they can hide it really well even at 0.2. And you also have the surface finish. As long as the filament almost breaks the lines by itself, you can hide those layer lines very easily. Now here you've got your line widths. Again, you don't need to touch most of them for your first prints, but all of those things really talk to the speed, the strength, the optical abilities of your print, and you don't need to touch them. What you see here, the white line, it's what is being described here. So that's the seam. What does the seam? What is the seam? As you've got a layer, that layer starts from somewhere. Okay, that's the first point of that layer, and consequently the last point of the layer. So as the printer is printing that last point, and it prints the last blob of polymer, what it then does, it does a small retraction, so it whoops the filament backwards a small distance to move to the next layer, and the result is a small blob. This is the seam. Now you cannot fully get rid of it because it's a restriction of the printing process. There are various things right here that can allow you to reduce the seam and how obvious it's gonna be. Mainly, it has to do with your temperatures, with your retraction speeds and distances, with just the finish of the item. It really is impacted by a number of factors that there are too many to describe right now in a very short video. But a seam can be a significant aesthetic degradation. So one of the things I like to do here, and that's a small tip, you just put your seam to the nearest, you slice it again, and it breaks apart that line. Now this is not always also perfect. If you've got a silky finish, that may actually make it even worse, and it's very difficult to tune in the settings without having a filament as a reference point, because there are certain filaments like marble that really the seam blends into the background really effectively, but for a silk finish it doesn't blend this well, so you gotta do your material settings. That's why you need to set your presets at your filament correctly. That's why you need to adhere to what the manufacturer is saying to reduce errors like this, the seam. The precision, you don't need to look at it. And then you've got your ironing and your work generation. Now ironing is basically your printer is injecting more materials into either your top surfaces or your entire item. This is gonna significantly increase the time of printing, but sometimes it creates significantly prettier prints, especially if you just go into the topmost surfaces and the top surface. If you choose to go the all solid layer decision right here, it's probably gonna add quite a lot of time to your print. I wouldn't suggest this, as it's basically putting extra material in between the lines to kind of to achieve this iron. This is what does it. Essentially re-injects material and it goes really really close with hot end, and it can really create some really very good top surfaces, but it's not unless you need it. It's not something that you should do at the beginning. Here you've got your wall generator, and this is a very important piece. It's the classic and the arachne. In this shape, we will not see a difference, but right here, you kind of see what the arachne does is it allows you to essentially close certain holes that may come up into your design due to an interplay between your design specifications and your printer settings. We said above that there is such a thing as a line width and such a thing as a nozzle diameter. Now, what happens if you've got design whose dimensions physically can only fit 2.5 lines? You might have a small gap in between them. This can somewhat be mitigated by the arachne, but that's exactly why I told you when you are designing an item, it's a good idea to be using line width and multiples of it as much as humanly possible to reduce the dependence of the wall generator. Now, the problem with introducing those, and you once again you see them, those gaps right there, sometimes they just be aesthetic problems, but fundamentally speaking, if you're introducing gaps inside the actual structure of your item, you may be introducing mechanical failure points that you didn't account for, you didn't even think about them. So it's a good idea when you are designing an item, especially if it's something functional, to be taking into consideration all those small details. You don't really have to uh, look at any other thing. So we go at strength here, and that's another important thing. So you've got your walls. Walls is the thing that connects the entire thing. They are significantly slower at their print speed, but they do add a lot of the mechanical capabilities of the final 3D printed product. Now, for me, two walls in almost all situations is good enough. One is a little bit too little, especially if you do some kind of vase mode creation. You might actually have static problems there. But two walls, they are extremely robust already. And if you've got walls plus infill, you're going to have a really robust 3D printed item. More than two walls, you're going to add a lot of printing time. I do not think you're going to find any upside in regards to either mechanical or aesthetic results unless you have a specific reason to do so. Bear in mind, if you are creating an item such as a vase, you're going to have walls to the outside, but also to the inside of the vase. So bear in mind, two walls for, depending on the shape, is going to be actually four walls. So bear that in mind. Now you've got the cells. This is basically layers that are at the top of the bottom that they have a different pattern. They can be very useful if you want to create a very good aesthetic result, especially if you combine them with certain bespoke printing plates that actually create imprints onto your especially bottom surface. You can create some fantastically pretty 3D printed items that can have this extra thing you are looking for. Now, this infill is the bread and butter of your item. Infill confers the most amount of printing time. If you go too low, you're gonna have almost no printing time. You're gonna have just the walls. If you go too high, you're gonna have a lot of infill. Depending on the geometry, the infill may be playing a bigger role than your walls do. Infill also confers certain optical, certain mechanical properties. If you've got something that is under a lot of stress, a bit more infill can allow you to carry more weight. We understand why that is. If you want some optical interplay, maybe you are using some kind of semi-translucent filament and you want to have a wow factor, playing with that infill can actually confer an optical result you want to. And it's really down to how much material you want to spend and how what is the function. I generally go on the higher ends, not 15% necessarily. I generally go over 50% unless it's something that really requires the infill. The reason I do is I like my creations that they generally have some functions to be a little bit more on the robust side, and it also allows me to kind of offset a little bit of the pressure of maintaining structural integrity from just the walls to walls and a little bit of infill. You've got more material to allow to absorb all that stress. You don't need to look at this moment at this part right here, and then you've got speed. Okay, and speed right here, you can really let the presets that you find in your slicers exactly where they are. Speed, once again, it's on a scale. The more speed you have, obviously you have the lower time, but the lower quality. If you want more quality, you've got to bring your speed down. And if you want really high speeds and really high qualities, you have to increase the price of your printer quite significantly. Now, generally speaking, most manufacturers are going to be providing you with information regarding to the top speed that you can achieve, but they also are going to giving you some recommendations about speed that you can expect the best combination of result and printing speed. Generally speaking, I would suggest against changing especially the wall speed, even though wall can sometimes confer a lot of printing time. Um, a nasty looking wall may get that part completely rejected. It's unacceptable or unrepairable. And if you also have structural problems due to really high speeds, like there was, it didn't properly melt the layers together and didn't properly bind, you may end up having with unacceptable structural damage that can get your whatever you're creating to not even be able to do basic function like standing on its own to fit. Whenever I change speed, I actually change speed more so to the infill rather than the wall. It's because in infill, if you get a little bit of a damaged infill or it's a little bit of nasty looking infill, you don't look at the infill; it's in the inside, and it's the infill is there to confer weight and structural properties, not so much aesthetic like the wall does, because the wall really plays a big role into the aesthetics of your 3D item. And travel and acceleration, again, I would let them as they are. There's no almost no upside for 90% of you to even touch them. It's a good thing to have them accessible, but I would probably not really touch them unless you are really experienced and you are looking to do a little bit of fine tuning. Now the support, very important part. So right here I've got disabled support. What is support? Sometimes you've got overhangs, and that's areas in which the relative angle from the rest of the body is so steep that the melted material cannot solidify fast enough. So you have to add the structure under them to physically support the weight until they solidify. It's almost like toothpaste, which solidifies really fast. But if you have to go too far outside the last layer, it's gonna droop. It's gonna bend over and it's gonna be damaged. Now, in most cases, in this slicer, if you need support, there's gonna be a message that says if you have disabled support, please enable. You have overhangs, and you can do it right here. There's the tree, and there is the normal. The normal is really more, if I can describe it as geometric. It's almost like a frame, and the tree is what it implies. It significantly, it really looks at to just do the minimal amount of supporting. Like physically, the support is going to be trying to be minimally touching the item. I would probably go with tree auto, especially if you are new, just because you don't need to go into the detail of how to create the supports. It's because it saves a lot of time and it's significantly easier to remove post printing. And if you have to really sand a couple of small areas down and paint them to fix the outside, to fix that contact point between the item and the support, it's a lot better to have small areas and sparse areas than to have larger areas. Sometimes the normal, the traditional, so to speak, can get a little bit overboard, depending, especially if you've made some bad settings. Now, Raft is something I've never used. Raft is basically a support that goes on the other side and just adds various layers. For me personally, unless you have some very specific reason to use Rafts, it's almost never worth it because you're gonna have to be removing those layers. And even if you have, unless you have some kind of double filament type of situation, which you're using PVA and PLA, for instance, to get that water soluble PVA, you're gonna get some surface degradation. So it's a good idea to remove as much surface degradation as you humanly can to avoid having to sand, prime, and paint them later on if you need to do it. So rough layers, unless you have something very specific, do not use them. All those things you don't really need to look at them at this point. They are very early. And here you've got at the other sections, you've got the bed adhesion. Very important for you guys. Now, in the previous videos, I told you that it's a good idea to be rounding out those corners whenever you need to, because this removes a lot of the stress and prevents, to some extent, warping. You can also have an enclosure. You can choose your temperature a little bit better. But one of the other ways to do this is introducing skirts and brims. Now, brims and skirts, basically, they do the almost same thing. Brims a little bit better. They add extra surface, and they essentially kind of offset the tendency that the first two layers have of warping inwards, because they literally give more surface to your first layer to adhere to your bed, so it doesn't warp until it settles. Now, you can. There are various brim types. I will not go into detail, but they are very good step. If you cannot round those corners out and you are design constrained what you have to create, adding a brim is a good idea. Now, sometimes if I have a print that has a particularly wide surface area, so it's a big rectangle, for instance. Even if I've made the steps of rounding the corners, I sometimes add brim as well, just because you've got a situation in which when you have something like a box, okay, and you are going into a square, because you have such a large surface, what can happen is that you will get warping because your layer is just too cold until you reach that next point of printing. So you're gonna have the development of all those forces that essentially your filament contracts, and it just pulls it upwards and curls upwards and that's how you get warping. So I sometimes add brim as well. Generally, I try to design things whenever I can with then the in mind with I would like them to be printed without a brim. Here you've got your prime tower that really goes into your multi materials and your multicolors, and this brim tower is basically when your nozzle is changing color. Sometimes it has to clean, that means purge, that means push the new filament and remove all the previous excess filament, especially if you have two colors that are very distinct. You need to go a little bit high to that level to make sure that you don't have any rest material in, because this could cause structural problems, color problems. It can cause any number of things. And the prime tower is basically the step afterwards, which it's a tower that's printing next to your item, and it physically just wipes the first few millimeters of the extrude from the hot end to make sure that if you are changing from white to black, for instance, filament, it just removes all the excess white or black filament, so that the next element of your 3D print is printed at the correct color, and you don't have a weird gray shade or like a line here that starts off black and maybe goes white because you didn't do the correct priming. So it's a very important thing if you're doing multicolor. I it's a waste sometimes, because when you are doing multi-material and multicolor, you can be spending a lot more into all those wipes and retractions and purges and the prime tower than the actual item. So my tip here, if you can do it, if you are doing multicolor, it's a better idea to print batch items and then go into the more complicated stuff. Um, and that's for the process section. Now, let me go here. We've got this prepare window, and I love it because it has right here, as I told you, the area. You are seeing the item, you are seeing the orientation, and here, if you click on the object, you have a bunch of really useful tools. What do those tools do? Now, I want to show you three tools really, and they are fantastic. First of all is here, variable layer height. Now, what did I do right there? And I believe we're gonna be able to see it right now. Yeah, it is what it is. Let me just variable layer height essentially allows your printer to change the height setting to get a slightly better quality. Now, what do I mean quality? Here, we've got activated the variable layer height. You see this area right here, because we have a very steep change in the curvature, we don't have enough time for the layers to hide themselves. So you are having almost like steps on a ladder. And if you look at that ladder from a distance, or that staircase, it may appear like a line, but the closer you get, the more obvious the steps become. That's what this is. Now, this is something you cannot fully um, solve, because that's just a limitation of the technique. By going with smaller diameters and thinner layers, you can almost make it disappear. I've made some prints at 0.2 millimeters that is almost non-visible, but you cannot always hide them. Variable layers allow you to have thicker layers whenever you need them, but increase the number of layers, or increase the decrease the thickness of the layers and increase the number of them whenever it would make sense for the quality aspect, and it's a very good thing to do. Now, as you see here, it's a scale, again, quality and speed. If I were to go the other way and you were to do that, you will see it's gonna just increase our layers, and you see here that is gonna be significantly um, more just ugly to look at. So you're gonna have to choose between quality and speed. Let me just reset it right here. The other thing I would like you to see, guys, is this one. This is the cut tool, and this is especially for you guys that are creating really large items and you want to create. Now, you could design things from your design software to be puzzled together, but you may want to cut them, and so you can do them on the Bambu and other slices as well. And right here, you can have two modes. That's the planar, and if I add connectors right here, I can just go there, click, and what does that do? Let me just give it a little bit of time. What does that do? It creates, first of all, the underside, one of the two halves that has connectors, but the other side is, as you see right here, it actually has the holes of the item. And this is something you can do, you can model on your software, but it's just a neat small trick you can use to actually get all those large pieces faster cut and connected. So that's the first thing. And then you've got your dovetail. And I love this. Let me show you. This is exactly what you see here. The dovetail separates those two pieces in such a way that it allows you to essentially create a crevice and almost have them slide in each other. Now, I've done this job professionally. I've had to put together large objects and glue them, and then do use modeling putty to hide away all those lines, and do sanding and painting. And I can tell you right here, this is a very useful thing, that dovetail cut, whenever you can apply it, because you're gonna have some degree of dimensional inaccuracy. There's gonna be a little bit of playing between the dimensions in the software and the actual dimensions of the physically printed products, because you're gonna have some uh, filament, the machine deviations. With dovetail, you basically have an area in which you can just slide them. They are oriented on their own, and you can just introduce glue or other adhesives in between that dovetail, and it becomes so much easier to work. So this was the second thing, and from there on, you can really investigate all those other useful tools. And obviously, you've got the scale tool, that allows you to increase your scale, maybe put it ununiform, maybe do it like that, and it's just a very useful thing to create if you want to just play with your item. And here you see the physical item, the actual dimensions and how big it is. And this is it, guys, for the slicer. The slicer is really conferring critical information about printing, and it can allow you to do some really cool things, and really allow you to go to this next level of creating really amazing stuff. Now, if you've liked what you heard, and I know you did, because I am exceptional in presenting somewhat complicated stuff, not very complicated, press like, subscribe, share this video with other people, and I'd love to see you on the next video. I would love to see you under these comments, telling me what more you need to do to see. Um, there's going to be a significant number of videos I'm going to be releasing, small examples, over the next few weeks and months, and I hope to see you there, guys. I'm Thanos. This is Thanos 3D Prints, and may the best to you guys. Bye.